Hello everyone. In continuation with the Thinking Machine series, I would like to introduce another point of view for building thinking machines. You should look at my earlier video series to get better context and continuity, which will help you get into learning groove. At its core, knowledge integration is a dynamic and continuous process, not a static event. It involves the synthesis of multiple, often disparate, knowledge models or representations into a common, unified framework. This goes beyond merely merging information with different schemas. It emphasizes synthesizing a deeper understanding of a given subject from various perspectives. A truly thinking machine would not simply accumulate static knowledge. Rather, it would constantly refine its internal models of the world, autonomously detect inconsistencies or missing information, and actively seek to improve its understanding, even inferring new knowledge that was not explicitly provided. This capability is a critical differentiator from traditional, static knowledge bases and highlights the importance of active learning and metacognition within integrated frameworks. The success and sophistication of integrated knowledge frameworks for building thinking machines will fundamentally depend on their ability to facilitate this dynamic, self-improving knowledge integration, moving beyond passive information storage to active knowledge management, refinement, and autonomous learning, which are hallmarks of advanced intelligent systems. The success of thinking machines hinges on architectures that can effectively manage this expressivity tractability dilemma, enabling both robust, interpretable reasoning and flexible, scalable learning. Let's dive deeper. Layer 1 is the machine's unconscious. It takes in the fire hose of real-world data and, using advanced self-supervised learning, organizes it into a meaningful map. It learns, without human labels, that pictures of golden retrievers are more similar to pictures of poodles than to pictures of cars. The output isn't a fact, but an intuitive, gut feeling, a vector that represents its holistic understanding of the current moment. Next is Layer 2, the machine's long-term, conscious memory. This is where explicit knowledge lives. It's a graph where we can state with precision that a bee is an insect and causes pollination. Critically, this isn't just a database of true-false facts. Every piece of information has a confidence score and its source is tracked. This allows the machine to reason with conflicting information and understand the origins of its own beliefs. Layer 3 is the magic, the translator. If Layer 2 is the word, apple, Layer 1 is the experience of every apple the machine has ever seen. The interface grounds the word in the experience. It also works in reverse. If the machine keeps encountering a new pattern, say, a strange pink fruit, the interface can abstract this experience and create a new node in the knowledge graph, effectively asking, "What is this thing?" This is how the machine learns new concepts, not just facts. Finally, Layer 4 is the active thinker. It's the executive function that runs the cognitive cycle. When faced with a question, it first orients itself, then activates the goal. It forages for information from both its rational memory and its intuitive experience. It generates multiple competing hypotheses, simulates their outcomes, and then selects an action. Crucially, it reflects on the result and learns from it. This engine is also equipped with a curiosity drive, compelling it to explore and learn on its own. Let's see it in action. If we ask, "Why are my apple trees not producing fruit?" A simple database might fail, but the IKF excels. The knowledge graph in Layer 2 provides the biological rules. Fruit requires pollination by bees. Simultaneously, the experiential layer in Layer 1 finds a strong pattern in this year's local data about a late frost. The cognitive engine in Layer 4 receives both inputs, the logical rule and contextual pattern, and synthesizes them into a brilliant, nuanced answer that is far more helpful than either piece of information alone. Looking forward, the field is characterized by exciting trends. the increasing prominence of neurosymbolic AI, a growing focus on enhancing human-AI interaction through more natural and empathetic systems, and the development of robust and flexible cognitive models capable of adapting to unforeseen circumstances. Emerging concepts, including neurocognitive models that bridge AI with neuroscience, multi-vector architectures designed for nuanced information processing, and agentic architectures enabling greater autonomy, point towards a future where AI systems are not only more intelligent but also more trustworthy, explainable, and seamlessly integrated into human endeavors. The ultimate realization of thinking machines will depend on the sustained, interdisciplinary effort to address these complex challenges and harness the synergistic potential of integrated knowledge. I will further share the more insights and details about how to build thinking machines and underlying principles in my coming video series. Please subscribe my channel and like the video so that I can bring interesting insights and updates on thinking machines.